So we are in the simulation environment. We have to specify these columns, and Radfrac columns. I'm gonna use this. It says absorber 1. Place this here. Right click. Then material streams. One goes for the solvent, another goes for the feed gas, the top one for the product gas, and the bottom one for spent solvent. Right click again. Let me zoom to fit, and let me rename this as scrubber. This is the, or better to say, clean. Yes, that's all. And it will be called spent solvent. This will be better to be called as fry. That's better. And this will be the feed gas. To make it more attractive, let me do some formatting. There goes the solvent and the feed gas. Sorry. Here comes the feed gas. Now we have to enter the data for the scrubber. This is the absorption column, and for our 2 feed streams. If you are not sure what to enter next, go to this home. There's this next icon as well. There's a big one. Click on this. The first thing AspenPlus wants us to put are the specs of feed gas. So for feed gas, we have temperature equals to 40. The pressure is equals to 10 bar. The flow basis will be mass. The total flow rate is equals to 100 kg per hour. Let me do this mass fraction. There is no water present in the feed gas. The mass fraction of nitrogen is 0.012. For carbon dioxide we have 0.982, and for acetic acid we have 0.006. We are done with the feed gas. The next thing is to input the data for the solvent. Here we are. The temperature of the solvent is 25. The pressure is 10 bar. Again, the flow basis is again mass. Total flow rate is 150. And let me choose this mass fraction. The solvent is pure water, as I've already stated. So we are done with the 2 streams, 2 input streams. The next thing that the AspenPlus wants us to provide is the data for the scrubber, or specifications for the absorber. So for that, either you can double click on this, you can click on this next button. So let me double click on this. The first one is configuration. I'm going with the equilibrium based calculation, not with the rate based. Number of stages. Acetic acid has so much greater affinity for water, so it's mean that less number of stages could work well here. So let me, as an initial guess, let's choose 6 stages. The condenser. We don't have any condenser in our absorber. And the boiler is none. Now we have to provide the streams data. The fresh solvent is entering into the absorber at stage 1, that is above stage, and for feed gas we will be having this feed gas. We have 6 stages, so let us say 6, and on stage we will be introducing this feed gas on 6th stage. For pressure, assume that we are operating this absorber under atmospheric conditions. So for that, 1.01 bar. We are done with the scrubber as well. Now here it says that required input complete. So we are ready to get results. AspenPlus is ready to provide us results. So without any further delay, let us run this simulation. There's no, so let us go to this blocks scrubber and results. Go to this split fraction. Here you can see that using 6 trays and with the above mentioned specs, the clean gas contains very less acetic acid. You can, in other words, we can say that nearly all the acetic acid goes with the solvent. So the better way of visualization is to get the stream summary. Click on this. Go to this mass fractions, and you can see that in the feed gas we have this mass fraction of acetic acid. We don't have any acetic acid in the fresh solvent, but in clean gas it's completely nearly acetic acid free. There is very small, it's nearly zero, you can say. Nearly all the acetic acid goes with the solvent. Hopefully you guys will like this video. Get me some recommendations, suggestions, topics in the comment section below. Don't forget to subscribe, like and share this video. Stay tuned for more content. Till then, it's ChemE. Thanks for watching.